Hello friends, welcome to my YouTube channel Engineering Modules. So friends, today I am going to discuss about nodal and mesh analysis with the help of numerical problems. I solve some numericals on the basis of nodal and mesh analysis, and through it I describe the basic principles of nodal and mesh analysis. So let's start, friend. So friends, this is the circuit diagram from which I explain nodal and mesh analysis. So we mainly come to know that nodal analysis is nothing but the use of Kirchhoff's current law, and mesh analysis is nothing but use of Kirchhoff's voltage law. So what is node? At first we know that node is a point in an electrical circuit where minimum 3 or more circuit elements are connected. So in this circuit, in this point, there are three branches. There are three branches connected to this point, and they all are circuit elements. So this is called a node. And also in this circuit, this is also a node because its right hand also have electrical circuit, electrical elements. This is also electrical elements, and this also electrical elements. So in this point, three electrical elements are connected. So these 2 points are called nodes. So I number the node is as 1 and this node as 2. So as per Kirchhoff's current law, we need to calculate the total current in this node, and the total current in this node must be 0. So the current in node 1 are, so this is the equation. In this branch, let's we assume in node 1 the voltage is V1. So in this branch current is V1 minus E1 because the current plus to minus drop. So less is minus. So V1 minus E1 divided by the resistance R1 equals to V by R equals to I. And this branch V1 by R5, and this branch V1 minus V2 plus E2 because minus to plus the voltage gain. So plus E2 divided by R2 equal to 0. So this is one of the equation. And the second equation at node 2 is, so for node 2, this is the equation. As we assume that V2 is positive, so the current direction is this, this and this. One outgoing, 3 outgoing currents, and all outgoing currents will be positive. And V2 minus V1 minus E2 because plus to minus divided by R2. This is the one equation current through this branch, and this branch V2 minus E3 by R3, and this branch V2 plus E4 by R4 equal to 0. So this is the equation for node 2. So in this way we calculate nodal analysis, and in this way we calculate also nodal voltages and the currents through all the branches. So this is the process to apply nodal voltages. In this problem, all the resistances have no either value. It all are variables, so this is not too possible to solve it. So this is the process. So now I am going to discuss about mesh analysis from this circuit diagram. So let's start. So for mesh analysis, we consider three mesh. This is one mesh, this is two mesh, and this is three mesh. But there are various loops. This also a loop, this also a loop, this also a loop. But mesh is unique closed path. So this is three meshes. We consider I1 to this mesh, I2 through current through this mesh, and current through this mesh is I3. So now we state equation for mesh analysis. So now we denoting the polarity of resistances as per current flow. So this is minus to plus, and this is as the current flow through this direction, so plus to minus, plus minus. For this current flow through this, so this is plus, this is minus, this is plus, this is minus, this is plus, this is minus. Current flow those three, plus minus this. This is the denoting of polarity. So now we come to the equation. So write the equation for mesh 1. So for mesh 1, the equation is E1 minus I1 R1 minus I1 R5 plus I2 R5 equals to 0. So how it is produced? Let's explain. So we see this is for mesh 1. Voltage is gaining minus to plus. So this is positive E1. Then the current through R1 resistance. This is plus to minus. So this is decreasing. So minus I1 R1. So this is minus IR1. Then the current through R5. This is plus to minus I1 R5. Big, but also the I2 current flow through R5. So this is the net resistance we calculate. Net voltage we need to calculate. So how? I1 R5 minus I2 R5. So we need this minus R1 R5 plus I2 R5, because this is plus to minus, so minus I1 R5, and this is minus to plus, so this is plus I2 R5. So in this way, for the mesh 1, the equation is formed. So for mesh 2 and mesh 3, in this way we form the equation. So the equations are, so these are the equation for mesh 2 and mesh 3. So in this way we calculate the mesh analysis of a circuit diagram. So there are three mesh equations: mesh 1, mesh 2 and mesh 3. So from this we calculate the value of I1, I2 and I3, because all of the variables like E1, E2, E3, E4 and R1, R2, R3, R4, R5 are known. So we easily calculate the current through all mesh and all branches, all resistance. So in this way we calculate all the things from mesh analysis. So this is mesh analysis, and we previously see that the nodal analysis for a circuit to also find the current. So nodal analysis is applied with the principle of KCL, and this is KVL. The main principle of mesh analysis is sigma IR equals to sigma V. So friends, this is all for today about nodal and mesh analysis. I provide you in my next video about some new topics on electrical or electronics engineering. So thank you friends, keep watching and please like, share and subscribe my channel. Thank you.